Hello and welcome to Squared Loops. I'm Pete. This is part of the Accelerator 1 course covering Node.js, Docker and Azure Kubernetes Service. This video will be covering Docker. Specifically, we are going to install Windows Subsystem for Linux version 2, then the Linux distro Ubuntu version 20 long-term support. Then we're going to install Docker Desktop for Windows. We will build a Docker image containing our Node.js application we created in the last session, and then we're going to push that Docker image up to Docker Hub. Let's get on. We're now ready to install Docker. We will follow the official Docker guide. The link can be found in the description below, or you can simply Google installing Docker Desktop on Windows. There are two different versions for installing Docker Desktop for Windows. The Hyper-V backend, which is the more legacy version of running Linux containers in Windows, where it would run a Linux VM in Hyper-V, or the newer Windows Subsystem for Linux 2, WSL2, which is where you can run a Linux kernel actually within Windows itself, not as a virtual machine. The Hyper-V backend and Windows containers, we will focus on Windows containers in another session. We will just focus on Linux containers for now, as they're slightly easier to get into and give us the flexibility to run Windows 10 Home Edition. For Hyper-V and Windows containers, you need to be running Pro or Enterprise Edition, whereas with WSL2, you can also use Home. To run either version, you need to have a version of Windows 10 that's running either 1903 or higher. To check the version of Windows that you have, you can right-click on the Windows Start button and then click on System. The screen that appears will show various information about your computer, such as the device name, processor, RAM, and near the bottom, the Windows specifications. This shows the edition of Windows. Here I have Windows 10 Pro, and also the version of Windows. I have 20 H2 and the OS build 19042. You may have the version 1903 or higher. As long as those versions meet or exceed the version that Docker needs, you'll be good to go here. We'll close this and focus on the Windows Subsystem for Linux 2 version. Although I'm running Pro, just to repeat, this does work on Home Editions, so you can follow along even if you don't have a Pro or Enterprise version. You need to make sure that you have a 64-bit processor, which most computers do nowadays, and 4 GB RAM. What we'll do is jump straight into installing WSL2, and we can do that either following the documentation or following along in this video now. The first thing we need to do is run Windows Terminal as an administrator. Right-click Windows Terminal, right-click Windows Terminal, and then run as administrator. Yes, we are sure we wish to proceed. After some feedback on the other videos, I've made the prompt a little bigger. Hopefully you can see as we go. You can see also the start, lightning bolt, and the tweaks we made by installing Oh My Posh earlier on. If you'd skipped that, that would explain why the visuals have changed slightly. What we need to do is enable the Windows Subsystem for Linux on this version of Windows, and you can use this command here. Again, all of the commands we're running will be available in the blog, so you can copy and paste rather than typing along. We'll run that now. So once the operation completed, the machine hasn't restarted, and that's because we passed the no restart flag. We did that because we want to set up version 2 while we are here. By default, enabling WSL actually installs version 1, which is now legacy. Version 2 gives us a whole host of extra features and what we need in order to run Docker Desktop natively. Now, on my version, when we've run it, I've received an exit code 2. I'm not quite sure why it's done that. So just to make sure that things are nice and clean, I'm actually going to close my terminal and try a fresh one. Sometimes these things happen, we'll just move along. So once we've installed WSL, we're now going to install the virtual machine platform. And this is the first step to installing WSL2. We can run that with this command. And that has completed too. What we want to do now is to install the actual WSL update. So we'll just close our terminals for now, go back to our browser and visit the URL I've just pasted. Again, available in the blog to get the path. This will install the WS2 engine that we need. We'll download and then execute this. Download has finished. We can show in folder. We'll right click and properties and then unblock the file. That's to show that we know it is safe to run. We'll now double click this MSI and it's not working. Okay, we'll do a restart. I think that will hopefully solve our issue here. So, restart. And we're back. We'll now install Windows Subsystem for Linux again with the upgrade. Go back to our downloads and run the update. This time it's detected that we're allowed to continue. Next. Yes, we do wish to continue. And that's installed. Now we'll run our terminal again as an administrator here. We want to use WSL2 as our default. So when we use the Linux system, it knows to use the new version 2. We can set that by running the set default version number and passing 2. That's it, done. We now have Windows Subsystem for Linux 2 installed. Bit of a mouthful, I think we'll just say WSL. What we'll do now is exit from the terminal and we can install a version of Linux onto our machine. There are various ways of doing this. One of the easiest is through the Microsoft Store itself. Microsoft over the years has changed its stance and now really does embrace open source, including Linux, no longer competing with that system. Search, and we're going to install Ubuntu. We'll use version 20 LTS. LTS standing for long-term support, so we know that this version will be around and supported as we need to. Once it's loaded, please feel free to have a read through. We will install this now by clicking the install button. That will now download. And Ubuntu has now downloaded and has been installed. We can view Ubuntu by clicking on the Start and typing Ubuntu. If we launch the application now, it will load in a window, its own little shell here. Take a few moments to install and get itself ready. We'll allow that to run. When it has finished installing, you'll be prompted to enter a Unix user account. This doesn't need to match your Windows username, but you do need to make sure that the credentials you enter here you remember, otherwise you won't be able to access the machine. I'm going to just use Pete and a password that I will remember. And we're in. We are now running Linux. We're running Ubuntu specifically, and this is Windows Subsystem for Linux 2. Who am I? Shows that it's me. I can list files, there are none, and I can look at the current working directory. We will exit out of this shell, and we will close the store as well. What we can do is, using the terminal, click on that. Just running as a normal account, we don't need to run as the administrator for this session. We can now click the down arrow, and you will see that Ubuntu version 20 has now been added to our list of shells that we can run. We'll run this now, and it will drop us into a mount. That's because we're running it as our usual account, and it knows to map our user account into the mount on the drive. If we run present working directory, you can see that it's put us into the mount C users Pete. If I list this directory, we show all of the various files that we have in our documents folder on our Windows machine. If we go to the Pete account that we had earlier when we ran it through the Windows start bar, you will see that there are no files here. So we can move around from the native home drive on Linux or back through to the files on our own machine. Gives us lots of flexibility when we're working with Linux, and you can run commands either in PowerShell or Bash here on Linux, depending on what best fits your needs. So that's WSL2. We don't need to use Ubuntu directly to work with Docker for Windows, so we will leave Ubuntu here and come back to that in another session. For now though, it's installed and accessible should we need it. And we will exit PowerShell as well. Now we have Windows Subsystem for Linux 2 installed, we're ready to go and get Docker. Let's do that now. We'll browse to Docker Hub, and this will allow us to download the Docker Desktop MSI. You can see here that it requires Windows 10 Professional or Enterprise if we use Hyper-V, or Windows 10 Home if we're using Subsystem for Linux 2. That's what we're doing. We can click the Get Docker button now to download the installer. And that's downloaded. We can browse to the folder it's installed. We will unblock this download to mark it as safe to run. And then run the installer itself. When prompted if you want to install, press yes. Wait a moment whilst the installer gets itself ready. As mentioned, we can see that we will be using WSL2 for the Linux Docker engine here, and we'll also add a shortcut to the desktop. Click OK to continue. The installer will then unpack all of the files ready for Docker to run. Now the files have been unpacked, Docker will install all of the various components. This may also take a few minutes. And that is Docker installed. You can see here it's asking us to log out, and we'll do that now. So we'll sign back in. You can see that Docker has started, and the little whale with the loading icons is also starting. We'll click on Dashboard. The dashboard shows that the Docker engine is starting, and it will take maybe a few more moments before it is available. The first time can take a little while. Whilst this is starting, I'm going to pin my Docker task icon so that we can see it more clearly when we're using Docker. Scroll down and choose select which icons appear on the taskbar. Docker Desktop is not currently shown. By turning this on, it will always appear in the taskbar by the clock. We can now keep an eye to check that it's starting and running as normal. The Docker engine has now started up, and it is ready and waiting for us to issue some commands. We will minimize the dashboard and jump into Windows Terminal. We can find out more information about Docker by running docker info. This will list all of the information about our Docker install. It will show things such as the version of Docker. It will also show the containers that are running. It will show the storage overlays, networking overlays, and other information. We can now run a simple container with docker run hello world. Because it is the first time we've run the hello world image, Docker will go and pull the image from Docker Hub. There might be various layers, in this case there's only one. And when it's finished pulling the layers down, it will run the container. You can see the output from the container is hello from Docker. This message shows that your installation appears to be working correctly. If we run the same command again, this time there's no need to pull the image, so it will just run straight away and display the same output message. We can check for any running containers with docker ps. Shows there are no running containers. Docker ps-a will show any containers that have run but then stopped. We can remove these if we no longer require them. Each container is identified by an ID and a friendly name. If you don't pass in a name when you run a container, it will be allocated just a random combination of words. You can use either the name or the container ID. You can also shorten the container ID to just the first few unique numbers. So we will do a docker rm to remove, and we'll remove container with ID 50. That's now removed, and the output will echo the container ID we've removed. We could also use the full identifier if we choose. Again, Docker will echo the identifier. Running docker PSA will now show that there are no stopped containers. So what we're going to do is to containerize our Hello World Node.js application that we created in the last video. We can browse to that now. Right click, open with code. Here is the app.js that we created in the last session, and we showed that you could run up this application and view a simple web page. What we're going to do is to delete the node modules, as we don't need these inside the repository and inside this package anymore. Instead, what we're going to do is to create a Docker file. And a Docker file is a way of scripting how we will package and run our Node.js application. We need to create a new file, right-click, new file, and the convention is to name this Docker file. You can see that Visual Studio Code is suggesting an extension that we can install to help us with the Docker file. We'll install that now just to make things a little easier with color coding our syntax, finding any errors, and generally helping us with how we develop Docker files. You can read more here. Going back. So the way Docker files and Docker works generally is every command in a Docker file creates a layer. And you can imagine building this image up layer by layer, brick by brick, until the application is finished. So what we need to do is to start every Docker file with a base image. This is the base image that we are building on top of, and we normally pull this down from Docker Hub. Use the from syntax, and as you can see here, it's suggesting we need to provide an image. We want to use the node image for Node.js, and there is a tag normally being a version number, so we want to use node 15, and we're going to use Alpine, which is a lightweight version of Linux OS kernel, and we can enter that. That will build a nice small image, so it's very snappy and very quick to run. That will be our base image, and then on top of that we need to create more images for our application. So a container is, by its very nature, a self-contained, isolated process. It doesn't have access to any of the host file systems, so all the files on the left here will not be visible to the container. We need to copy the files into our container. To do this, we can use the copy command. There are others, but copy is going to be sufficient for what we want to do here. We want to copy all of the files, so dot from our host machine, and we want to copy them into a source folder on the container. So inside the container, you can imagine, is now a folder called src, and that will have all of the images on the left copied over. Then what we want to do is we want to change to this new folder, and we want to install all of the node, the npm packages. To do that, you can use the run command, and this will run any bash scripts that you want into the container. So we want to change to the source folder we created, and we also want to run ampersand means and npm install. Just like we did before when we were running node and npm locally, we can run the same command in our container. So that will change to our folder and run npm install. That will use our package JSON to get any dependencies, in our case Express. Because we have the lock file here, it will retrieve the exact same versions we ran earlier, so we know that the dependency tree will work for us. The next thing we want to do is to expose a port. Expose port 80, which is the default HTTP port, so that traffic can access our container. To do that, you simply run expose, and then the port is 80. Finally, we want to start Node, just as we did when we were running it locally, and this command is very simple. The cmd command. There are others that we'll get into future lessons, but cmd is what we're going to use now. We want to run node, and the parameters to pass to this node application is the path, the full path, so source app.js. That will run our application for us. And that's it. With just a few simple commands, we've created our first Docker file. Use a base image, copy all the files in, npm install to get all of the modules, expose port 80, and then run node. And it's always worth looking back through what you've done. I've just noticed a mistake. Where we've exposed port 80, of course that's the default HTTP port, but we're actually using port 8080 for our app.js application. If we go back and look at app.js, we're exposing on port 8080. So we need to make sure that we expose that port, not the default port. As long as these two match up, so we could change either the app.js to use port 80 or our container to use port 8080. That doesn't really matter which way round we do it. And then we'll jump into the terminal, integrated terminal here, and we can now build that Docker image. We can use Docker build, and we want to tag the image once we've created it. That way it'll create a friendly name that we can use to identify the image rather than a char, a hash, which is slightly harder to remember. And we'll tag our image hello world node.js and a colon so that we can give this a version or a tag. We're going to call this version 100, and the final parameter is the location of the Docker file. By passing in dot, it will use the Docker file in the same folder that we're running this command in. Press enter, and Docker will send the command to the Docker daemon that's running in the background, sends the definition up, and the daemon will start to download all of the images. You can see there that I have already pulled down node image, so it just uses the cache. It has copied the source folder, run npm install, has exported the layers and completed. The char I was mentioning before, this is the unique char for that image, and the friendly name that we're using, hello world node.js, with our tag v1. This has all happened within a Docker container, so totally isolated from my machine. You can see that the node modules folder has not been created, and the benefit of containers is that we can run all of these in isolated silos rather than all overwriting or conflicting with each other on a single machine. We can now run this container, and we will use docker run, just like we did with hello world, but we'll pass a couple of additional parameters so that we can expose the container to the outside world. P to expose a port, and on the left side is the port from our physical computer. This is the port we exposed with the firewall in the last lesson, and then on the right of the colon is the containers port. Now we also said 8080. They can be different, and we'll show you how that works shortly. For now, that will do. And then we need to say what image do we want to use. We want to use our new hello world node.js v1.0.0. We run that now. The container will spin up and expose our node.js application on 8080. You can see the same output as we saw before. If we jump straight to our other computer and refresh, you can see that that's still working. If we go back and press Ctrl C to stop the container and refresh, you will see it's still running, and that's because the application is running behind the scenes in Docker PS-A, and you can see that it's created a minute ago and it's been running for about a minute. We could also run the container detached straight away so that we don't have the console freeze and lock like this. For now though, what we can do is run docker stop, and we can pass in this unique container code 987. That will stop the container. And if I refresh my browser now, you can see that it's no longer retrieving a response from that container, and it can't serve the web page. If I do docker psa, you can see that it was created a minute ago, but has since stopped. What we can do now is we can remove that container. And if we look at the running containers, there are none. What we can do now is we can do the docker run, and this time we will run in detached mode. This will just return with our container ID straight away and then back into the prompt so we can look around and work as normal. So if we look at the running containers, we can see that this SHA that was reported when we started running the container is indeed the ID of our hello world image created a few seconds ago, and you can see that the ports are mapped 8080 on our machine into 8080 on the container. Can also quickly flip to the Docker desktop we have running here, and you can see that already it's updated automatically and the containers running. This is our hello world Node.js, and its friendly name is running on port 8080, and the images shows that our local machine has got a few images. So hello world, obviously we pulled down to test that that was working, and hello world Node.js, you can see that's running version 1.0.0, and the ID for that image. And there are various options we can do here to sign in and inspect what's going on and push and pull, which we'll cover on later on. You can stop. You can jump into a container just as if it were a remote virtual machine, a bit like SSH or WinRM. We'll cover that again in a future session. For now, though, you can see that the Docker desktop's quite a nice user interface, and they're constantly evolving the features that are in here. For now, we'll minimize that and jump back to our application. So this is working again, and it's all looking good. What we'll do now is we will stop our container, and this time let's use the friendly name, and we can remove it too. We can also run the container with a friendly name. Let's call this squared loops. Oops, I meant name. That's better. So as before, it gives the container ID, but if we look at the container this time, you'll see that the name is the name we provided. This makes it much easier if you want to stop a container and remove containers, because you can use the name that you know of rather than the typo, rather than using a container ID. And we'll remove that as well. Perfect. Now what we want to do is to push our container image up to Docker Hub so that we can use it elsewhere. There are various ways of doing this. The first we'll use is the command line, but we can also use Docker Hub, and we'll look at those different options now. The first thing we'll do is to sign into Docker Hub in the browser so that we can see what we're doing. I'll do that now, and we'll go to Docker Hub, and we can click Docker Hub. And you can sign up if you haven't already. It's totally free to get started. I will sign in as I already have an account. And I have one container already pushed up, Hello World container, where I was playing around prior to this. We can dismiss that. Once you're signed in, you can look at your various settings and accounts. You can look at your repositories and your organizations. If we go to repositories, very much like GitHub, the repositories are projects. So the Hello World container that I pushed up before, you can see sits under my account with a name. And like Git and GitHub, you have push and pull commands. So we'll go through that now, and we'll push our new container up to Docker Hub. So we're going to log into the Docker CLI with Docker login, and we pass our Docker Hub username, squared loops. When prompted for the password, enter that now. And we should receive login succeeded. We can now push and pull Docker images with our account without needing to log in again. If we look at our list of Docker images, Docker image list, you can see that we currently have two, and Docker World, Hello World Node.js is our Docker image we've just created. For us to push this up to Docker Hub, we need to prefix that with our Docker Hub username, just like we would in Git. So we can now tag our image with Docker tag hello world node.js v1.0.0, and then the new tag is exactly the same, but with the prefix of our Docker Hub name, hello world node.js v1.0.0. If we now look at the images again, you will see we now have hello world node.js and squared loops hello world node.js. You'll notice that the image ID is exactly the same. That's because the images haven't changed. We've just given it a new identifier, and that will allow us to push this up to Docker Hub. To do that, it's as simple as running docker push and then the fully qualified image name. So hello world node.js version 1.0. It will prepare and push those images up to Docker Hub. Shouldn't take too long. And then at the end, it will give us a digest code and a size showing that everything has been pushed up correctly. Here's the digest showing that everything has been pushed correctly, and we can return to Docker Hub, go to our repositories, and refresh. And there is our new image, Hello World Node.js, updated just a few seconds ago. We can browse into here and you can see version 1 was pushed a few seconds ago. That was pushed by me. We can obviously add descriptions and logos and all sorts of things to make this more attractive, but for now, that shows how we would push up images using the command line. We could make a simple change, so is we'll change the page slightly so that we say hello world with containers. Let's try that. Going back to our terminal, we can run through the same sequence of commands as we did before. So we can run docker build. This time we'll increment the version to 1.0.1 and run that. It will run through the process of building the image, so pulling down the new node packages that are needed, so Express, installing all of that inside the container, and then outputting. We have built the Hello World Node.js tag. We could have built it using straight in with the squared loops /, but for now I will add that as a manual step just to help understand the process. So if I now look at tagging, we can tag the new version for both. And we could try pushing the new version as well. You'll see that the layer already exists is shown for the parts that we've already pushed before. It'll just push the diff much quicker the second time. We'll report the digest, and we can view that if we refresh on the browser. Version 1.0.1 has now been pushed, and we would continue working in this way. To show the more direct route, we could do a Docker build straight in with squared loops. Let's make this version 2. And we can do a push straight away. So you don't need to always retag. It depends on your workflow whether you have the need for local images or whether you can include your prefix in the tag. And there's our new version, version 2. We can do the same thing with the Docker desktop. Let's sign in here. You can see the images that we've been creating through the CLI here. And we can also view our remote repositories for our user here as well. If we were to build another version, let's build version 3. Now using the Docker desktop, we can refresh. With version 3, we can either run the image or we can push to Docker Hub. We'll push now. You can see the progress bar going up and the same output with the digest code shown here. If we go to the remote repositories, you can see that we have version 3 appeared less than a minute ago, and also using the website Docker Hub, we can see the version 3 has been pushed as well just a few seconds ago. So now we've pushed our images up to the internet onto Docker Hub as a public repository. We can pull these from anywhere in the world. Even if they were private, we could pull them down as long as we had the sign-in credentials. And that's exactly what we're going to do in the next course. We're going to use Azure and Azure Kubernetes service to pull down our Docker images and to run them in the cloud rather than from our machine. And I'll see you in the next session.